Okay, welcome to lesson 40. So what we're doing now, we're proving an identity. This is really the same thing as lesson 39, right? But before, what we were doing was just simplifying. But now when they say proving, what that means is that we're going to make the left side of the equation equal to the right side. So same thing, we just got to simplify it, but then we want to come out with one side equaling the other. Okay? So this has all kind of been talked about in the last lesson, so I'm going to kind of skip that and just kind of get right to it. So, a couple of ways to do it. You can prove it by actually putting in like a number, like 30 degrees into the angle, or you can do it by just making one identity equal to the other identity. So for this one, we're going to put in 30 degrees, and then this one it says n pi over 4. But to tell you the truth, I'm just going to do one because the other one will be the same. Like it'll be really similar. So, all right, so let's go tan theta sine theta plus cos theta equals secant theta. So I'm going to rewrite this with 30 degrees. So it'll be tan 30 degrees times sine 30 degrees plus cos 30 degrees is equal to secant 30 degrees. Okay, so we're into the realm of the unit circle thing again now, right? So tan of 30 degrees, if I want to figure that one out, right, I would go to my unit circle or have it memorized, right? So unit circle here, and I'd be looking at 30 degrees, right? Okay, so when tan is 30 degrees, well, here's my sine or my y value, and here's my x value. So it's really going to be 1/2 divided by root 3 over 2, right? So that's going to be the process there. And maybe you have it memorized by now, maybe you don't, but if you do that, you end up with tan 30 is root 3 over 2, right? That was just sine over cos. That's what we did there, right? So I can say root 3 over 2, sine of 30. So sine of 30, right? So sine of 30 degrees. Sine is the y value, so that's just a half. So sine of 30 is a half plus cos of 30 was, so cos of 30, I do the same thing, root 3 over 2. Oh, I made a mistake, sorry guys. Tan, that first one, root 3 over, not 2, root 3 over 3. I'm so used to writing root 3 over 2. Okay, cos of 30 degrees, cos of 30 degrees, looking at your formula sheet, is root 3 over 2. Okay, so times root 3 over 2 is equal to, all right, so now secant 30 degrees. One sec.
Mrs. Hartford, Mrs. McCann.
Okay, sorry, there's an announcement happening there. All right, so secant 30 degrees. Well, the inverse of secant is cos, right? So it's really 1 over the cos value. So looking on the unit circle, right, the cos value was root 3 over 2. So secant is 2 over root 3, right? So 2 over root 3. So I can, yeah, so let's write that. So 2 over root 3. I'll just leave it like that for a second. Well, technically what we're going to do here in a minute, though, is we are going to multiply, just to rationalize it, multiply the bottom and the top by root 3. Right? So in the end, I'll write it down here. That's going to be equal to 2 root 3 over 3. Okay. So now, all we have to do is clean up the stuff on the left now, over here. Okay, so if we do that, we end up with, so this one would turn into root 3 over, and then 3 times 2 is 6, plus root 3 over 2. Okay, so then, just adding these fractions here, we end up with 4 root 3 over 3. Right, I just would have changed, I would have multiplied this by 3 and that by 3, right? And then collected like terms to get that is equal to, um, 2 root 3 over 3. Sorry, that didn't work out. Sorry, when I combine those like terms, that should have been 4 root 3 over 6, which would have simplified to 2 root 3 over 3 is equal to 2 root 3 over 3. Okay, so the left side equals the right side there. Okay, and that's it. That's kind of the gist of it, right? So, yeah, that's doing it by actually throwing a number in and seeing if the numbers work out. I'm gonna skip, like I said, the pi over 4 one because it'd be very similar. Okay, so let's move on to the next one. So now it says prove the following identities. So we're not going to throw, we could throw like actual angles in that we know and it should work out as well. But we're just going to try to make one side look like the other side, right? So what I'm going to do, usually one of our strategies is to rewrite tans or secants or, you know, cotangents and that type of thing in terms of cos and sine. All right, so I'm going to rewrite this. So 1 over tan theta. Well, I could write 1 over sine over cos, or just, you know, cut to the chase and write this as cos over sine. So cos theta over sine theta, right? Because it's just the inverse of tan, right? Okay, plus, and now normal tan is just written as sine theta over cos theta is supposed to be equal to 1 over sine theta cos theta. All right, so now strategies here. Maybe you're kind of thinking about this, trying to make them look the same, right? I'm looking at this side, and you've got it written over sine theta and cos theta, right? Well, if I look over here, right, if I actually added these things and made a common denominator, well, that would be sine theta, it would be over sine theta times cos theta, right? So that's probably the strategy I want to do. So I'm going to write this fraction here as with a common denominator of sine theta times cos theta, right? Right, so to do that, what I had to do was I had to multiply the sine theta part of this, right? I had to multiply this by cos theta and the top by cos theta. Okay, and on this side, I had to multiply this by sine theta and the top by sine theta. And what you can see now, maybe you can see, is that cos theta times cos theta, that's cos squared theta, and then plus, and then this part is sine squared theta. Maybe that's starting to ring some bells. That's one of our identities, right? So 1 over sine theta cos theta. And when I was looking at this too, right, looking at what I have written there, this is really close, other than like, you know, this part of it in 1, you know, I'm like, oh, okay, yeah, maybe if I look at my formula sheet, that's one of my identities. Cos squared theta plus sine squared theta is equal to 1. So we can say 1 over sine theta cos theta, sorry, I'm making this messy, is equal to 1 over sine theta cos theta. So, worked out. All right, next one. Okay, I gotta zoom in a little bit. Zoom. Yeah. Okay, next one. So, yeah, so now looking at this one, I'm kind of trying to think through this one, right? Like, there's only so many things you can do. First off, I try to see, like, okay, are any of these my identities? You know, maybe I go to my formula sheet, and I'd be kind of looking through these, you know, and being like, well, maybe it's something like that, I don't know. But not really. Nothing really pops out yet. But I'm noticing that I've got sine theta and sine theta there, and I've got two different terms. Like, maybe if I factor out a sine theta, maybe something else will become a little clearer, right? So let's try that. So I go, okay, well, let's factor out sine theta. So if I do that, I end up with 1 minus cos squared theta is supposed to be equal to sine cubed theta. Okay, so I'm looking at this being like, okay, all right, so I got a sine theta out. Is this anything, right? And I'd maybe look to my formula sheet and be like, all right, cos squared and 1. Where have I seen cos squared and 1 before? Well, what about that one, right? Cos squared and 1, they both show up in the same equation. It's written a little different, right? But if I rearrange this, I could move the cos squared theta over to the right, and that would now be 1 minus cos squared theta. So 1 minus cos squared theta is equal to sine squared theta, which is perfect because I'd like everything to be in terms of sine, right? So I can rewrite this as sine theta, and now all of this stuff, right, that can all be turned into sine squared theta, which I think maybe you'll see where we're going here. Sine theta times sine squared theta is sine cubed theta, which is equal to sine cubed theta. So the left side does equal the right. All right, this one's going to be a mess. It's a long one, right? So looking at this guy here, like we said, like I was saying, is that if one of the sides, like the left or the right, is like bigger, like if it's more complicated, you usually want to work with that side and see if we can simplify that down to this side. Okay, so what we're going to do, it's going to be a lot of space here, but this stuff in brackets, the way it's written like that, it doesn't do me any good. I don't have any identities where, like, you know, sine plus cos all squared, like that's not a thing, right? So I need to expand all of that, and I need to expand all of that. So if we do that, you would end up with sine squared theta, and then plus the middle part would be plus 2 sine theta cos theta, plus, and now like the back side of it here would be cos squared theta. Okay, so that was all just this part expanded, right? So now if we work on to the next part, I'm just going to leave this as minus, and then in brackets I'm going to put this all written out here. So this will be, so now expanding this would be sine squared theta minus 2 sine theta cos theta, and then plus cos squared theta. Sorry, that was kind of messy, but hopefully you get the gist there. Okay, and that's all supposed to be equal to 2 sine 2 theta. Another room there. Okay, so now we just need to clean this all up, right? So it kind of sucks. I got to write it all again with distributing this negative into everything. So I'll start my process again. So sine squared theta plus 2 sine theta cos theta plus cos squared theta. And now changing all the symbols on all of these ones, I'll have negative sine squared theta, and now this will be plus 2 sine theta cos theta plus cos squared theta. Okay, it's supposed to be equal to 2 sine times 2 theta. Alrighty. So now, I'm looking at all this gibberish, and what I'm going to do is I'm going to assume, right, because I got, here, let me put color here. What if I combined my sine squared theta with this cos squared theta, right? So just adding them, right, because that is an identity. Well, that's equal to 1, right? So that would just be, you know, 1. You know what? Doing it that way would make life more complicated than it needs to be. It would work doing it that way. But what I'm going to do instead is I'm just going to say easy, like a lot easier, sine squared theta, and I have a minus sine squared theta. Let's just cancel those, right? Because something minus itself is just 0. Okay, and then cos theta, cos squared theta. I've got another. Oh, sorry. Maybe you guys noticed that I made a mistake here. That should have been minus, right? So then cos squared theta minus cos squared theta, they cancel. Okay, and then what I'm left with is I have this guy and this guy left. Well, if I rewrite that as, well, 2 sine theta cos theta.
Don't the controls is just working on this.
Okay. So that is one of our identities as well, right? That's one of our double angle identities. That's equal to sine 2 theta. Sine 2 theta. And this one is equal to sine 2 theta. Okay, so then if I have sine 2 theta plus sine 2 theta, well, that's the same thing as 2 sine 2 theta, which is what I wanted it to be, right? 2 sine 2 theta. Okay, moving on. So C. Alrighty, so what we're gonna do, is, again, I'm gonna work with this side and try to see if I can get that side. One thing to kind of keep in mind while you're doing that, though, like when I'm looking at this side, is maybe try to keep in mind what some of the identities are that might be, right? So I'm gonna look here and see, okay, 1 and a 2 cosquared theta. See if I've got anything like that, right? So 2 cosquared theta. So yeah, it's something like this, right? So just keep that in mind. That so it's 2 cosquared theta minus 1, and this one is 1 minus 2 cosquared theta. Well, if I factored out a negative, that would end up being 2 cosquared theta minus 1, right? So yeah, just keep. I have the luxury of knowing what the answer is, so so we're gonna have to do that in the end. But for now, I'm just gonna leave it, and I'm gonna work with the right side. So let's go 1 minus 2 cosquared theta. And now what I'm gonna do, I'm not a big fan of the way this looks right now. So what I'm gonna do, first off, I'm gonna see if any of these are identities, right? So I go to my formula sheet. So tan squared theta, minus 1 or plus 1. So tan squared theta minus 1 or plus 1. Well, what do we got here? Okay, yeah, right. So I'm looking at this one, right? So tan squared theta plus 1 is equal to secant squared theta. So maybe that'll be part of my toolkit here. So I could call the bottom here secant squared theta, right? So we'll just stick with that. And now I'm going to deal with the top here. I can't really do anything with that. So what I'm going to do is I'm going to rewrite the tan squared theta as sine squared theta over cos squared theta, right? And now going minus 1 doesn't really do me much good. So what I'd like to do is I'd like to rewrite this thing as over a common denominator. So I can rewrite this 1 instead as cos squared theta on the top and bottom, right? Cos squared theta divided by cos squared theta, right? Because that is just 1. I've just rewritten it a different way. And the reason why I did that, right, so that's all on the top, is because now when I combine those, right, with like a common denominator, on the top I'm going to have sine squared theta minus cos squared theta. Okay. Yeah, so okay, so we do that. On the bottom, like I said, we're going to call that secant squared theta. Alright, so working our way down. We've got, I'll rewrite this again here. Maybe I'll write in the new color so you can see the different steps here. So 1 minus 2 cos squared theta is equal to, and now we're going to rewrite this, the top part here, like the sine squared theta minus cos squared theta all over cos squared theta, and then that is all over, I'll put that in brackets so you can kind of see what the fractions over the fractions thing. 1 over, because I'm going to rewrite secant squared theta as 1 over cos squared theta. Okay, so what's going to happen here now is that I can flip the cos squared theta upside down, right? So I can flip this guy, right? This guy here, upside down, right? So cos squared theta over 1. and multiply, hopefully you can see that the co-squared thetas would end up canceling. Maybe. Hopefully you can see that. If not, write it out like so it's over here, right? So you'd say cos squared theta over 1, right? And now you can see the cos would cancel with the cos on the bottom over here. Okay? All right, so that's what happened there. So that made it a lot simpler, right? Because now I've just got cos squared theta minus sine squared theta minus cos squared theta on the top. All right, so now let's move over here. So now I've got 1 minus 2 cos squared theta is supposed to be equal to sine squared theta minus cos squared theta. All right, so now I'm looking at this being like, all right, is there anything I can do here? Well, so let's look. Let's see. Do I have a sine squared theta minus cos squared theta on my formula sheet? So sine minus cos. So if I'm looking here, I'm like, all right, so sine minus cos. I'm like, well, that looks close right there, right? Cos squared theta minus sine squared theta, right? So it's close. What I can do is I can factor a negative out of this one. So let's do that. So we'll go 1 minus 2 cos squared theta is equal to negative, and then what I'm going to end up with is, like, it'd be cos squared theta minus sine squared theta, it'd be negative sine squared theta plus cos squared theta, or the way I like it written better, so because it looks like the identity, cos squared theta minus sine squared theta. Okay, so 1 minus 2 cos squared theta is equal to negative, and then cos squared theta minus sine squared theta, that's equal to 2 theta, cos 2 theta. That's equal to, so negative 2 cos theta. Sorry, no, that wasn't right. It was equal to cos 2 theta. So cos 2 theta. Okay, so cos 2 theta. So now, again, I'm just going to be looking for identities here. So maybe cos 2 theta. Maybe I can rewrite cos 2 theta as one of those guys. So let's try that. So we'll go cos 2 theta. I got a few of them. I want it to be like, 2 cos squared theta and 1. So 2 cos squared theta and 1. This one's looking pretty promising, right? So I'm going to rewrite that now as 2 cos squared theta minus 1. So 1 minus 2 cos squared theta is equal to negative, I forget what it was. What was it? 2 cos squared theta minus 1. 2 cos squared theta minus 1. And then this is looking good. I can distribute the negative into that. So we've got 1 minus 2 cos squared theta is equal to negative 2 cos squared theta plus 1. And those are the same thing, right? They're just rearranged different. So they check out. All right, phew. Hopefully that made sense. All right, so yeah, make sure you guys practice. You can see that it's a lot of just fiddling with it, just making sure that you can try this, try that. This wasn't like the one way to do it. There probably would have been other ways to do it too. So don't think that, oh, I'm just I'm doing it wrong because you didn't do exactly all my steps here. These steps could have been different, right? Okay, so that's it. Yeah, that's it for that video.